My pleasure to invite our keynote speaker this morning, Dr. Robert Easter. Dr. Easter, if you would work your way over to the podium, I will introduce you. Dr. Easter is president of the University of Illinois. He was head of the Department of Animal Sciences, dean of College of Agriculture, Consumer, and Environmental Sciences, and interim vice chancellor of the university's Urbana-Champaign campus. He is an expert in swine nutrition. He has numerous publications and has spoken to audiences in the U.S. and 30 other countries on livestock feeding. In 2006, he was appointed by President George W. Bush to the Board of International Food and Agricultural Development, BIFAD. He serves on the Illinois Agricultural Leadership Foundation and the Governor's Committee on China. Please help me welcoming Dr. Easter.
Thank you very much. It's a pleasure to be here once again. I had the opportunity to be part of this conversation last year, and obviously it's an area that's near and dear to my heart, and I truly appreciate the effort that these societies are doing to determine where the organization, and in particular members of the organization, should be going relative to your role and the challenges that we face going ahead. I do suspect, though, if I'm invited back again next year, it'll be to pay dues and be a member, so I want to be cautious about that. First, I want to be perfectly clear. I'm not an agricultural engineer. I'm an animal scientist. I've had the opportunity to work over my career with those in agricultural engineering who focus on animal facilities, but I have really no expertise in your domain. I am an agriculturalist. I have over time, I think, developed some perspective around that. And as a dean, as a chancellor of a campus with a major college of agriculture, and as president, some sense of how agriculture and in agricultural engineering is viewed within at least U.S. public land-grant universities. The question that keeps me, and I suspect some others, awake at night is this one, and that is, what will the world look like that our grandchildren will experience 15, 20, 30, 40 years from now? And the more vexing question, what are we doing to shape that role? And in your particular case, what's the role of your society? What's the role of your profession in creating that role? The questions are obvious, and they've been mentioned already this morning, and they'll be explored in more detail as this program goes forward through the day. My role is to give some general perspectives around that. Simply, will there be enough food? Can we make the food system safe as it goes through the changes that it must to supply an increasingly urban world? How are we going to deal with this vexing question of water? And I think the speaker spoke at a very interesting point. And on the one hand, as an economist would say, there's too much, and on the other hand, there's just not enough. And overarching all of that are the issues of contamination and pollution and loss of water quality. Energy continues to be an area that is a challenge to us, and how will we each in our own world deal in these topics with changes that are taking place in our climate, and are the essentials of life and the fundamentals, food, water, the things that are essential to sustaining a healthy life, sustainable, and will they be around in adequate quality for our parents? Our children and grandchildren. I want to kind of touch on each topic lightly, and I understand my role in this program is to more or less set up for the series of specialists who will delve more deeply into these themes. Can we produce enough food? Obviously, it's not a question. I'm sure you're familiar with the postulate that Parson Malthus put on the table back in 1798, and he suggested that human populations increase geometrically while production increases in an arithmetic ratio. In fact, it's grown in amazing quantities of people as we've addressed problems of health, as we've addressed problems of providing food and habitat for this ever-increasing population. And I don't think sometimes that we fully appreciate how successful we have been. If you think about the technologies that existed, the means of producing and preserving food, moving food that existed at the turn of the 18th century or at the turn of the 19th century and where we are today, we made incredible progress. The question that we continue to ask is, can we do this as we go forward? And as we made progress in food production, we've done it through a variety of fairly interesting means, things that perhaps were not that challenging. We expanded the amount of cultivated land. As I travel across the Midwestern United States, flying over it, I recognize the different patterns in the color of land in the early spring and what was once forested and what was not was prairie. And it's interesting the extent to which that great prairie was in fact also forested. And we took away the forest and we cultivated those lands. We've applied science. And in the process of applying science, we've discovered new technologies, and we have been in our history very effective, I think, in transferring that new knowledge to application and then extending that application to the field through educational systems. And there's been market structures that have encouraged growth, and there's been a supporting infrastructure. Across a number of countries over the past 100 years or more, we've evolved very effective agricultural research and educational systems. And I don't think one can undervalue the impact that those systems have had on providing adequate food supply for the world. Sitting in my role today as a president of the university that's challenged financially, as many public universities with an agricultural mission are, I don't think one can feel particularly secure in where we may be in the years that go ahead. There are challenges in sustaining the system that's been so successful to this point. As we talk about what we've done to produce more food, sure, there have been negative consequences, and we have recognized them and we have addressed them in a variety of ways. I grew up in an era where there were many who remembered the terrible challenges of the Dust Bowl from the 1930s in the United States, where soil erosion was a big challenge. We have issues around pesticides, depletion of geological water supplies, deforestation, but yet we've addressed a number of these very effectively. I mentioned the Dust Bowl of the 30s, and you can only go online and pull down some horrific images of what things looked like in the prairie states of the United States during that period. And then you can look at other sites that talk about where we are today. And agricultural engineering through soil and water efforts had a major role in developing not just the technologies, but the underlying systems of applying those technologies, along with agronomists and others who have really done a great deal to preserve the productivity of our lands. You as a field introduced the concept of minimum tillages. Tillage is a way of minimizing soil loss, minimizing degradation of soil quality by excessive tillage. And others developed the necessary pesticides and management techniques that allowed that to work effectively. Again, it's an important role that agricultural engineering has played. So I compliment you on the role that you've had in the past in making parts of the U.S. and global agriculture sustainable, and I challenge you certainly to continue to think of how you do that as we go into the years of the future. It's already been mentioned today that the food challenge is in part one related to population growth, and we see regularly the projections that the population will increase to something in the vicinity of 9 billion individuals by the year 2050. It used to be 2030, and before that it was 2010. It reminds me that I'm getting older because those dates keep moving along. But the population growth, if we go from our current 7.2 billion to 9.1 billion, the projection that's made by some bodies in the United Nations, that's about a 26% increase, and certainly it's a major driver of food demand. And I don't think we can ever ignore also the critically important role that per capita income growth around the world has on food demand. If you look just at the need to increase food production, to increase the growth in population, you would suggest that it probably needs to be on the order of 25 to 30%. But if you add to that the impact that income growth has, the changing population from buying very simple staples, grains and oilseeds, to a much more varied diet, a diet that includes additional amounts of animal protein, that includes edible oils, etc., you understand that it's not just an increase of 25 or 30% in production, but perhaps a doubling, in fact, of overall production. And there's good examples of that. As people have a growth in income, it's often associated with a movement to an urban setting where there's employment opportunity. And with that urbanization and the growth of the major cities around the world, and as one moves to those cities, you see the change in the food budget, as I've spoken to just a moment ago. As one looks to where we have come, and we're almost to 2020, so these are no longer speculative data, the growth in urban centers is taking place in the developing countries of the world. It's not something that's a phenomenon in places like the U.S. and Canada, where our cities grew several decades ago and to their more or less current size. The enormous growth, the enormous movement of people, now more than half of the world's people live in urban centers as opposed to rural settings, creates real challenges as we look forward, but it also is reflected in the changes in income, and it reflects changes in the food budget where people are seeing their food consumption. These data go back to a period of rapid urbanization in India, China, and Brazil, and they reflect the reduction in the case of China, for example, in cereal consumption, the increase in products from oil crops as edible oils were added to the diet, and also this very substantial increase in consumption of animal proteins, meat, fish, and milk products. And it's that then that becomes part of our challenge as we go forward. I made this picture a few years ago in Beijing in one of the Lotus hypermarkets in that city, and I was struck as I walked through there. I've gone to China for a long time, and I was struck by the extent to which the demand for meat products has grown and the extent to which that demand is being served by these very large marketing organizations. And if you're going to produce more animal products, there's a demand for more feed grains to support that, and the associated environmental challenges and other things that come along with those production systems. As an animal scientist, which is my profession, as was indicated in the introduction, I think that one of the areas that ag engineering, agricultural and biological engineering has not given sufficient attention to in recent years is animal production systems. I think the technologies that have come to us from basic science over the last several decades offer opportunity for innovation, and I would encourage your profession to spend time thinking about that. We have also this challenge of food safety, but in food security, and I put a definition up because sometimes people are confused with security refers to having a secure food supply. That's enough food. Safety is the issue of keeping it safe, as it doesn't have pathogens or other harmful contaminants. And these, like all issues, are multifactorial. Obviously, they're technical fixes, but public health policy is a major part of it. Infrastructure, the ability to maintain cold chains, moving from production centers to points of consumption, and simple education so that those both in the supply chain as well as consumers understand the issues, and then monitoring that so it's a system without corruption so that food is truly maintained in a safe farm as it goes along. I've been impressed as I've traveled around the world over the last 40 years, the extent to which traditional cultures developed reasonably robust methods for protecting food for local same-day consumption. You go into a country that's in the early stages of development, and you always see the local morning market where fresh meat, fresh products are sold for consumption that same day. The real challenge we have today is how do you move massive amounts of food? And if you think about the quantity, there's truly incredible from where it's being produced somewhere in the world. And those somewhere locations are those locations where it makes sense from an economic perspective, from an efficiency perspective to produce things, how do you move it and protect its safety from where it's produced to those world population centers, and do it safely and do it efficiently? I was in Kenya 2 or 3 years ago, and out in a region in the Rift Valley where milk is being produced. The typical dairyman has 1 or 2 cows. Every day he collects his milk and takes it to a collection center. And this particular center outside Eldoret had about 2,000 farmers dumping their can of milk into a single tank that then was transported to Nairobi. How do you ensure that one contaminated supply of milk, one contaminated can, doesn't create a contaminated quantity for all? These are not trivial challenges, and I think it's important to remind ourselves that there's, around the world today, much of the food production occurs at the bottom of the pyramid. It's not at the technically sophisticated operations that you see in this part of the world, but it's in very small and very underdeveloped systems. I want to transition now to water, and water for me is a bit of a personal story. I'm originally, my rootstock, if you'll use that term, are Midwestern. My family had been in the Midwest for a century or more. In the early 1900s, they were lured to Texas, to Southwest Texas, by the promise that that area would become the next Central Valley like California and be a place where people grew rich producing vegetables. And it was all based on water. And there's me back about a long time ago, many years ago, and my dad operating a vegetable farm, irrigating with one of the most inefficient methods of all, but it felt good to a 6-year-old kid to walk in that irrigation ditch. A few years back, I think it was USA Today ran a story about my hometown, and these are the images they depicted, totally different from the image there. The water is gone. When my grandfather moved there shortly after 1900, you drill a well in the ground and water just bubbled up. When my dad stopped irrigating in the 1960s, you were lifting water about 400 feet, and it was no longer economical. The geologic water has disappeared. 2 years ago, I was about 100 miles north of Delhi, sitting down in a wheat-growing region with a group of farmers to talk about their issues. And I asked, "What's your problem?" And they said, "It's the cost of electricity." And that kind of surprised me because I was curious to know how they used electricity. They use it to pump water. And the water table is dropping year by year, and as that occurs, the cost of getting water to the wheat crop goes up. And I was told by others that there's about a 20-year supply left in that aquifer. So what happens when that becomes a challenge? Well, if you think about the Green Revolution that was so successful in the 60s and 70s, irrigation was a key pillar along with plant breeding. Geologic water today is being used at an unsustainable rate, like my home area of South Texas, like that region in northern India. It's not going to be there forever. And agricultural use, as we hear from places like California, is challenged by growing urban demands. And we also face the challenge increasingly of contamination of our water supply with industrial and other chemicals. 2 years ago, the World Food Prize went to an agricultural engineer from India because of the work that he had done with water. And I think it was important that that recognition occur because it underscores the critical, vital role that water and water quality has going forward in our global sustainability. Related to that in other areas is the challenge of bringing technologies related to water, but also crop production in other areas to small holdings farmers, keeping in mind that most of the production is taking place in very small operations. Their information needs are significant. And how do you make the transition along that final mile? This is an image from the USDA website I pulled up a couple of years ago of how we did it in the U.S. in the 1930s with the extension advisor who went out and talked to farmers. And he didn't just talk about knowledge, but he also observed, and he adapted his message as he went from farm to farm and observed what worked and what didn't work. Today, we are challenged. We can no longer afford to put 50 or 100,000 extension employees into a landscape. We're challenged to transfer information to smallholding farmers in parts of the world where their educational systems are not particularly robust. And it would seem very simple to do that with online information, put it on a cell phone or whatever. But the challenge is, how do you adapt that information? How does the system learn from the experiences when the farmer applies that in a very local setting, and then adapt the message as you go forward? It's interesting, The Economist, about a month ago, I guess May 3rd, so it's more than that now, had an article, and it referred not only to China but also to India, and the tendency that seems to be in place that smallholding farmers are moving into larger aggregations of farms. So maybe what we're seeing coming over the horizon in developing countries, developing agriculture, is an increasing farm size, which enables more efficient application of advanced production technologies. I want to touch on energy. Had I been giving this talk 3 or 4 years ago, we would have probably spent a lot of time talking about energy. And if it was in 2008, we would have talked a great deal about the competition between food or fuel. And there's a paradigm shift, and there's no question about this. I attended a 2-day energy conference in Houston back in January of this year. And I guess I was blown away to get some understanding of the technologies that have now emerged for extracting both natural gas and petroleum from the earth, and how that's changed the paradigm. The U.S., and as this article in the Wall Street Journal indicated a while back in May, I think, is becoming a oil petroleum exporting nation. But if you're a thinking person, and we all are, we realize that the growth in energy demand just continues. And certainly having petroleum available today, or natural gas, is a delightful thing to enjoy. But like the water supply locked in geologic formations, that supply of fuel is also limited in its long-term sustainability. So I would encourage us as we go forward to continue to look at ways of producing energy in through different means, and also, of course, to the efficiency with which we use energy. In some sense, it's almost unfortunate that we are being distracted from a research focus on energy by the availability. I want to turn now to sustainability for a minute, because at the end of the day, all of these things have to work. And Casey Ting is here in the audience. When he joined us at Illinois several years ago, I was dean of the College of Agriculture, Consumer and Environmental Sciences. And for whatever reason, one day I said to Casey, how do you define sustainability? And he had a project funded by NASA for many years related to the Mars mission. And he said, think of a spacecraft. You can't add anything to it. What's there is all you will ever have. And if you look at the image of planet Earth, it's very much the same way. It changed my thinking about sustainability. We have a finite resource. It's this planet. And if we use it up and we use the resource, then it's not going to be there for future generations. And that's how I think about the issue of sustainability. Climate change, I'll touch on that. Couple of our scientists 10 years ago at the University of Illinois started this rather curious thing called Soy Face. It has to do with free air concentration enrichment over soybean fields, and of course they've expanded it now across a number of different cropping systems. And this rather curious hexagonal contraption there is a release tube that allows you to inject gas into the atmosphere. And by using technology, they're able to establish and maintain, regardless of how hard the wind blows or whatever, a fixed concentration of carbon dioxide, hydrogen sulfide, whatever you want to maintain over that crop. And it's been an incredibly rich laboratory to understand what will take place as we see changes in our climate and our world's environment. And one of their graduate students, now an associate professor on the faculty, put this in an article back in last year. Overall, these open-air investigations of the direct effects on atmospheric and climate change on soybean and maize, the two Midwestern crops, paint a pessimistic picture for future productivity. And I think the next point's critical. However, the experiments also reveal significant variation within germplasm, suggested that targeting breeding could lessen the impacts of climate change. Science can help us solve problems. Well, coming to the end, what's the opportunity for agricultural engineering from a non-agricultural engineer's perspective? I guess the question that quickly comes to mind, or the opportunity quickly comes to mind, is I think about what I know about your profession, is that over time you've not necessarily been where the fundamental discoveries were being made in physics, fundamental discoveries in biology, but you have been very effective as a profession that integrates knowledge across a variety of fields, I think, including biology, and the name a number of years ago was a very astute move, to integrate knowledge to build solutions. So as I think of my home department, my home field, animal science, as I think of agriculture, biological engineering, crop sciences, horticulture, food science, the opportunities that we in our professions have to work with those who are in the areas of discovery science to translate that into solution of problems is enormous. And there are challenges in doing that. One of my frustrations as a university leader is I truly understand the importance of having faculty who do really fundamental discovery science. It opens up whole new venues of opportunity for society, and people get Nobel Prizes for doing those kinds of things. Those are the tools that when others use to solve problems, and it's difficult. It's easy to celebrate and recognize those fundamental discoveries, but it seems that it's always more difficult to celebrate and recognize those who do multidisciplinary work, building on the discoveries of others. And as we struggle to find research support in the form of funding, finding funding for multidisciplinary work is often difficult. I could give a lecture on how the U.S. government, after the Second World War, made decisions about where its investments would be made and what role was to be played by the private sector. And it's worked in many instances, but there are also areas, I think, especially in agriculture, where there's been a lost opportunity relative to multidisciplinary work. Well, I'll wrap up quickly. My time is exhausted. The future belongs to those who create it. I truly believe that, and I think you are doing absolutely the right thing by thinking seriously about how you create the future for your society, for your profession. And I would remind you that of the power of the first draft. And what I mean by that is getting the ideas coalesced into a concept that can be put on the table. Others can take shots at it, but having it there is an incredibly powerful thing to do. So I very much appreciate the opportunity to be here, and I respect what you are doing creatively, engaging in this conversation that's so critical to the future of human society.